So as I said, we're going to start with the imaginary numbers. And part of that has to do with the fact that if we're thinking about what this means, this is a square root. And a square, if I think of about a square, if I go 2 squared, that's 4. If I say 3 squared, that's 9. So what it means is a number times itself. So this 2 tells me that it's 3 times 3. Or if I have 4 squared, then it's 4 times 4, which is 16. It's not 4 times 2. Be careful about that. I still have some students that mix that up. It's the exponent tells you how many times to use the base. So since it's a 2, I'm going to go 4 times 4. 5 squared, that's 5 times 5, right? Well, what if I did negatives? What if I had a negative here, like this? Does that change the answer at all? It doesn't, because negative 2 times negative 2 still gives me positive 4. 2 negatives make positive. Negative 3 times negative 3 still gives me positive 9. So these, whether or not they're positive or negative, it doesn't change the answer. So if we kind of think about this idea here, then how did we get a negative there? If we're taking the square root of it, that means that it was squared, right, to get there. So we can't possibly have a negative number because remember, no matter what, if it's positive or negative, I get those positive answers. So that's why we call this an imaginary number. It's not really possible if we think about what a square means. So as soon as we see a negative under the square root sign, what we do is we take that out, and the square root of negative 1 times 48. So we're going to kind of separate these out. And the square root of negative 1 equals, oops, not j, I, like that. So this equals the square root of negative 1. So when we see the square root of negative 1, we take it out and we replace it with I. So we have I, the square root of 48. Now let's deal with square root of 48 because we do need to break this number down. So let's go ahead and break this guy down into some pieces here. So let's see. I'll leave it blue for a minute. Not green. So let's see. We can divide by 2. And actually, if we divide by numbers that we already know are squares, so something along these lines, and they could be bigger than this too, then that makes it a little easier. So let's go ahead and divide by 4. I know 4 is a square. The square root of 4 is 2. So I already know that. So if I divide by 4, I get 1 and I get 2. Well, hey, 12 can divide by 4 again, and that would give me 3. So these guys are squares. The square root of 4 is 2. The square root of 4 is 2. If I have to take more than one out, I need to multiply them back together. So it's a total of 4. This one gets left behind. So I'm going to end up with 4 square root of 3, because that got left behind. It got left under the square root. But the one piece I did bring down, I need to make sure I bring down the I. So it's 4i square root of 3, because the 4 and the I just get multiplied together. Just like it would be a variable kind of stuck out there. It's just a variable with a very, very specific meaning. All right, 3. So let's go ahead and check that guy, and we are good to go. All right. And I know when we did this in class, I think we did this at one point where we listed all of our squares. So it's definitely a good idea to have them listed. But when you're doing something like this one, so this is multiplying, we still multiply these numbers together just like we normally would. So we'd have 15 times negative 3, and that would get me negative 45, like that. And as soon as I see the negative sign, I'm going to kind of divvy that up so that it's like that. And I can take that I out. So I'll take that I out in a minute. 45 can divide by 9 and 5. And I'm picking 9 on purpose. 9 is a square. So now I have all my pieces kind of divvied up. So I did that a little different than the tree, just so that we can kind of still see it all under the square root sign. So this guy means I. The square root of 9 is 3, and 5 doesn't have one, so it's going to get left behind. So remember, whenever I take out more than one thing, I have to multiply them together. So I have 3i times the square root of 5, like that. So 3i, make sure you use this I, because if you try to do it on the computer, oh, it does work. I thought it wouldn't let me type it in, but it is letting me type in the I there. 5. Okay, with this one, so let's go ahead and write this one out. We have square root of negative 63 over the square root of 9. So let's separate this out. We have negative 1. 63 divides by 9 again, and that's going to be 7. 9 times 7 is 63 over 9, the square root of 9. So any number divided by itself, and we can look at these all separately. Since they're all being multiplied, they're all factors. So 9 divided by 9 cancels out. It becomes 1. So I actually cancel these away. 7 doesn't have a square root, so that's going to be left over. But negative 1, that the square root of negative 1 is I. So I'm going to end up with I over times the square root of 7. So I square root of 7. Check. All right. So this is just kind of some multiplication rules, and we've dealt with factors before. This is just kind of adding that new piece in with that imaginary number. When we're adding or subtracting numbers, we treat them just like we would any other variable, actually, when we're adding and subtracting. So we're still doing like terms here when we do this. And pay attention to this. If this is a minus sign, then it needs to be given to each piece here. So that's one that they do that sometimes just to kind of see if you know what to do with it. I have like terms here. So 5i and 6i, well, that's 11i. I'm just going to add them together. Go with any other numbers. Negative 4 plus 6, they're opposites. So I'm going to subtract, and the bigger number is 6, so it's positive. So there we go. I combined those guys together. We just add them, add the like terms, just like we would any other number. So it's 11i. Uh-oh. What did I do? Oh, I forgot a negative sign there. That should be a negative sign. See, I just totally forgot to write it in there. So negative 4 minus plus negative 6, that doesn't mean we subtract. It means we add and keep the negative sign because they're both negative. So this should be negative 10. So that, oops. I don't know why the 2 didn't go away. There we go. So that definitely changes it, just not writing down that little negative sign. Does that happen? Sure, it happens. Go back and check and make sure you wrote the question down right. That's the first thing I always check, is to make sure I didn't miss something when I was writing it down, because that is the easy thing to do here. All right, so with this guy, so I want to do FOIL. I want to multiply these guys together. So I have negative 2 times 2, that's negative 4. Negative 2 times 3i, so that's going to be negative 6i, because negative 2 times 3 is negative 6. And then the I gets tacked on just like it's a variable. Let's go with, I guess, pink for this one. So I'm going to move to this second piece here. Negative 3i times 2 is negative 6i again. Negative 3 times 2 is 6, and times I, just tacks it on. And then I have negative 3 times, negative 3i times 3i, that's negative 3i squared. So now this is actually going to cause a little bit of a different thing. Remember, I equals the square root of negative 1. So if I square this like this, so I squared is equal to the square root of negative 1 squared. Well, if I square that, it's actually just negative 1. Because remember, I can take 1 out. If it's squared, that means that the square root is just that number, is negative 1. So this ends up being negative 1 times negative 3. So that when we see that I squared, once we start adding other variables to it, or not variables, sorry, other exponents, we need to start applying those other exponents. It definitely makes it a little different here. I have some like terms I can combine in the middle here. So I have negative 6 and negative 6, that's negative 12i. And then these I need to multiply together. Negative 3 times negative 1 is positive 3. So now I have some more like terms I can add together. Negative 4 plus 3, that's negative 1 minus 12i. So now that is simplified as much as I can go there. Negative 1 minus 12. Uh-oh, what did I do? Let's go back and make sure I didn't mess up any of the pieces here. -2, +2, -3i, +3i, -4, -6i, -6i, uh-oh, I see what I forgot to do. 3 times 3 is not 3, it's 9. Silly person that I am. So this should be 9. And this should also be 9, because -9 times -1 is 9. And then this becomes +5. Oof. Getting too busy talking here and not paying attention. All right. So, okay, so when we have an imaginary number in the denominator, we need to rationalize it. Meaning we need to basically move it from the bottom to the top. It's not allowed to be on the bottom, okay, or in the denominator. So what we want to do is we want to multiply by the conjugate. And what the conjugate is the same thing, except this is subtracted. So we have plus here, we have minus here. So that's the only difference. We're just changing that, not the first number, only the second number. And we're going to do that by the top and the bottom. So we're actually going to multiply both the numerator and the denominator by the same thing. So on the top, and I'm just going to switch my numbers here, I have 6i times -2, so that's -12i. 6i times -3i, so 6 times -3 is -18. I times I is I squared. Remember, that's going to be -1. I squared equals -1. Over, on the bottom here, we want to make sure we're doing the multiplication. So we have 4, -2 times -2. And then we have -2 times -3 is +6i. And then top, so going to the next number, we have 3i times -2, so that's -6i. So if you notice, what's going to happen here is these guys are going to cancel out. And we're not going to end up with an I in the denominator at all. And this will be a little bit silly at first because it's going to look like we have one, but it's going to be a square. So 3 times -3 is -9, and then I squared. Remember, again, that means -1. So let's go through and kind of simplify this again. This is -1 times -18, that's +18. Over 4, this is not -9 times -1, that's +9 instead of all that. So we have 4 plus 9, and that gets us 13. 6i minus 6i cancels out. So really all we have left is 13 on the bottom. So I could have actually written this more in the middle. So this is rationalized. This is what we want to do. We want to move that imaginary number from the bottom to the top. 12i plus 18. And I want to make sure the entire thing is divided by 13. So if you notice, I didn't click the fraction ahead of time, but I was able to highlight the whole thing, and then I did the backslash on my keyboard, or you could click fraction and it will insert the fraction bar across the whole thing for you.